Hey everyone, welcome to Revolution Games Academy. In this video, we're diving into one of the most essential concepts in Unity, game objects. Whether you're building a simple or complex game, understanding how to create, manage, and manipulate game objects is fundamental. Let's break it down. Game objects are the core building blocks of your Unity scenes. Think of them as empty containers that can represent anything in your game: characters, props, scenery, or even UI elements. They don't have functionality on their own, but once you attach components to them, they come to life. These components define how the object behaves, whether that's physics, movement, collision detection, and so much more. You can create game objects in several ways. First, open the Game Object menu and select Create Empty, or choose specific options such as 3D models, lights, or user interface elements. Alternatively, you can right-click in the hierarchy window and select an object type, such as a cube, light, or camera. When you create a game object by right-clicking the canvas, you will get a game object with Rect Transform. It is specifically designed for 2D UI elements and also primarily used for UI elements like buttons, panels, and images that are placed within the canvas. But when you create a game object by right-clicking the hierarchy window, you will get a game object with Transform in it. The Transform component is used for regular 3D game objects. It controls an object's position, rotation, and scale in the 3D world space. Additionally, you can rename the game object either in Hierarchy window or in Inspector window to suit your needs. Once your game object is created, you can easily manage it. You can activate or deactivate game objects using the setActive method. For example, GameObject.setActiveTrue will activate an object, while GameObject.setActiveFalse will deactivate it. To remove it from the scene completely, use Destroy Game Object. You can assign the game object in the inspector window and observe its behavior during runtime. To position, rotate, and scale your game objects, you will use the transform component. Here are some examples that demonstrate how to change a game object's position, set its rotation, and adjust its size. Let's move on to the next topic. Components can be added to your game objects either through the inspector or by using scripts. In the inspector, you can select the game object, click on Add Component, and choose the desired component, such as a rigid body or collider. To add components through code, you can do something like this. In Unity, finding and accessing game objects is essential for interacting with your game world, and there are several methods to do this. You can use GameObject.find to search for an object by its name, which is useful if you know the exact name of the object in the scene. Alternatively, you can use GameObject.findWithTag to locate objects by their tag, making it efficient for identifying specific categories of objects like player or enemy. For example, you can find all objects with a specific tag using GameObject.find, game objects with tag. Another efficient approach is to reference game objects directly through the inspector by creating public fields in your script and dragging the desired objects from the hierarchy into those fields. If you need to create copies of game objects during runtime, you can instantiate them with code. For example, this is especially useful for spawning objects like enemies, pickups, or projectiles. Using instantiation efficiently allows you to create a dynamic and interactive gameplay experience. However, always manage the instantiated objects properly, such as destroying them when they are no longer needed to prevent memory issues or performance drops. To optimize game object management, you can use object pooling, which reuses objects instead of constantly creating and destroying them to save resources. You can also mark static objects as static to optimize rendering and lighting for objects that don't move. Additionally, you can organize game objects into layers, which helps with collision detection and controlling which objects are visible in the scene. To keep your project organized, always name your game objects descriptively, like player or enemy spawn, and keep related objects grouped together in the hierarchy. Prefabs are your friend when you want to reuse game objects. Avoid hard-coding references. Instead, use the inspector or flexible systems, like scriptable objects, for better maintainability. That's a wrap on today's tutorial about creating and managing game objects in Unity. I hope it helped you understand the basics and improve your workflow. If you found this video helpful, don't forget to like and subscribe for more Unity tutorials. Stay tuned and happy developing.